Okay, I want to do two more examples with you. You don't have this sheet that says example 9 and example 10 on it, so you're going to have to make your own. But here's example 9. It's a toboggan, mass 50 kilograms, being pulled by a force acting upward at an angle of 53.13 degrees. Okay, so it's being pulled by a force acting upward. This angle in here then is 53.13 degrees. So this will be your Fx, and this will be your Fy. The mu, the coefficient of friction, is 0.3. And the toboggan accelerates at a rate, Ax, of 1.5 meters per second squared. And the question wants you to find what's the force you're pulling with. And of course, acting back here is friction. Okay, so we can still get an expression for our force, but this time we aren't going to be able to find them. So in the x direction, it's adjacent, so it'll be cosine. So cos theta will equal Fx over F. So Fx will equal F cos theta, but now even if you wanted to, you would not be able to get this number because I didn't give you the F. The y looks similar. It's sine theta is equal to Fy over F. So Fy will be equal to F sine theta, but again, we can't get the value. So don't bother filling in the 53.13 there. There's no sense of having numbers mixed in with your letters. Now we'll go to sum of the forces in the y direction. This toboggan that you're pulling is not moving in the y direction, so Ay is still 0. So acting in the y direction is Fn, Fy, and Fg. Assuming we're calling up positive, then Fn is up and Fy is up, so they're both positive. Fg is down, it's negative. Still looking for Fn always in the y direction, so take the other two over and they change sign, so Fg becomes positive, Fy becomes negative. So now write it out as Fg is mg and Fy is F sine theta. Don't fill in any numbers, okay? Because there's no sense of having numbers and letters. So just carry all your letters. You can't find a value there because you don't know what Fn is. So now go to sum of the forces in the x direction. In the x direction, you have an Fx minus friction, and that's equal to max. Fx we have up here, it's F cos theta. And friction, we know, is from the Fun equation, is just mu Fn. Now we're looking for the F, but there's an F here, but there's also one inside the normal force. So where Fn is, we need to sub in what we found Fn to be. So F cos theta stays here, minus mu, and then brackets mg minus F sine theta is equal to max. Okay, so now you have two terms with the unknown in it, two terms with F, but one stuck inside a bracket. So you need to expand the bracket, multiply through by the negative mu, so it becomes minus mu mg, and then minus mu times minus F sine theta becomes plus mu F sine theta is equal to max. Keep the two terms with F on this side, take the term without F to the other side. So it'll be F cos theta plus mu F sine theta will equal max, and when I bring this over it becomes plus mu mg. Now I have two terms with F in it, so factor the F out, and it becomes cos theta plus mu sine theta equals max plus mu mg, and now to get the F by itself, divide by the brackets. So max plus mu mg over cos theta plus mu sine theta. And now fill your numbers in. A was 50 kilograms, M was 50 kilograms. A was 1.5 meters per second squared. Mu was 0.3. times 50 kilograms times 9.81 meters per second squared divided by cos of 53.13 plus 0.3 times the sine of 53.13. And again, remember, everything on the bottom should be in a bracket when you type it in your calculator. Okay, and assuming you can type this in your calculator correctly, you should get 264.464 newtons. Okay? All right, that is example number 9. Example number 10 looks an awful lot like it, actually. You can replay this if you don't get, and then ask me about it either in the group or tomorrow. Example number 10 says a box is being pushed by a 400 Newton force downward at an angle. So this time I give you the FC, so I'm not mean twice in a row. 400 Newton force downward at an angle of 36.87 degrees. So this will be Fx, this will be Fy. So of course there's also an Fg going down here, and an Fn going up, and friction going backward. And it tells us the coefficient of friction is 0.2, and the acceleration is 2 meters per second squared, and this time I want you to find the mass. So just like we did before, we can find our Fx and our Fy components. So cos theta will equal Fx over F. So Fx is equal to F cos theta. Again, don't put your numbers in. They're only going to get in the way right now. Just even though you can find these, don't. Okay? So leave it as Fy is equal to F sine theta and Fx F cos theta. Because now when we go to some of the forces in the y direction, still going to 0, we'll have Fn. This time it'll be minus Fy minus Fg equals 0. So when you take them over, they both become positive, Fg plus Fy. So Fn is equal to mg, which we don't know, plus F sine theta. So there's no point of having a number for F sine theta when you can't get a number for mg. That's why I was saying don't fill it in. So go to the sum of the forces in the x direction. In the x direction, you have Fx minus friction is equal to max. Fx is F cos theta from up top. And friction, we know, is mu Fn. And Fn is this whole thing. So we have F cos theta minus mu brackets mg plus F sine theta. So it looks very similar to the last time, except for a sine. And now once again, you're trying to solve for m this time, and it's stuck inside the bracket. So multiply through minus mu mg minus mu F sine theta. And now take the m's over to get them on the same side. So bring this guy over here. So F cos theta minus mu F sine theta. And it's going to become max plus mu mg. So pull the m out of this side, ax plus mu g, and then divide by the bracket. So you'll have m is equal to F cos theta minus mu F sine theta. And then you're going to divide by ax plus mu g. So F was 400 newtons, cos of 36.87, minus mu was 0.2 times 400 newtons, sine of 36.87, divided by ax was 2 meters per second squared plus 0.2 times 9.81 meters per second squared. Again, remember the bottom needs to be in a full bracket, probably to go into your calculator. And if you can punch this in your calculator correctly, you should get 68.6522 kilograms. So really, the difference is don't fill your numbers in, because you're solving for something in the FN.